Hello and welcome to our presentation today on the top 5 signs you may need a ProGrade 3D printer in your program. My name is Alex Baddick and I work for Amtech Company, a local reseller for Stratasys in the Mid-Atlantic region. The point of today's presentation isn't to convince you that a desktop 3D printer doesn't have a place in your program, but it's just to give you some of the signs that we've seen that indicate that maybe you're ready for the next step for a ProGrade 3D printer to solve some of the problems that are commonly associated with desktop printers. Desktop printers still have a place even if there is a ProGrade printer in your program because they're a lot less expensive and you can add capacity easily, but a ProGrade printer will solve problems related to consistency, reliability, and throughput. Amtech Company has been around since 1979, providing technical education solutions to educators in the Mid-Atlantic region. A significant part of our business today is helping educators integrate digital fabrication technology similar to what you see in the rendering on this slide into classrooms. We can help with an individual piece of equipment or help you with an entire lab. So with that, let's start with our first sign that you need a ProGrade printer, and that is you spend too much time tweaking your models. Desktop printers require trial and error printing. You print the part out and you realize it doesn't fit together with the other part you printed out, so you have to go back and tweak the model until you can print it out enough times that you figure out how to get those parts to fit together. This obviously takes a lot of time, and the problem is, what if you change materials, or what if you print it out on a different type of desktop printer? That other desktop printer is probably going to have similar limitations but different limitations, and therefore the part no longer fits if you use a different model. So you're going back to the drawing board often to tweak your model to fit the limitations of your 3D printer. ProGrade printers, on the other hand, are accurate and repeatable. Every single time you print the part, that part's going to come out within the same tight tolerances. This is shown by this image here. This is from MakerBot with their method, which does actually have a heated build chamber, which is what allows a ProGrade printer to be accurate and repeatable. And you can see the bearing, they're trying to fit that into 2 parts printed on different printers. It's the same STL file. The one printed on the method with the heated chamber fits right in. The one on the desktop printer does not. And if you've tried something like this where you're integrating parts together, you've probably experienced this often with desktop printers where you do have to go back and print something out a couple of times until you can get that part just right to fit how you want it. Next up, you spend too much time tinkering with your printer. Desktop printers generally require quite a bit of tweaking and calibration. A lot of times you have to do this right out of the box, and then you have to do it constantly because they're using lower end components and a less rigid frame that just loosens up over time, and you have to go back and constantly tinker with it to keep it working the way you want it. The other issue with desktop printers is you generally have limited support. It might be email, it might be web forum, it's rarely phone support. Sometimes you might get live chat, but another issue is a lot of these companies that produce desktop printers are from Asia or Europe, and you're going to have significant time zone differences, so it's going to be difficult to get somebody live. This isn't necessarily a problem if you're printing every once in a while, but if you rely on your printer day in and day out, this can become a big issue when you have a problem that pops up. ProGrade printers don't have the problem with support because you can call somebody in your local time zone, but they also don't have the problem because they just work. They let you spend your time and energy on your design and not on your printer. Our third sign is you don't trust your printer to print overnight. I hear this all the time with customers that are surprised when we install a ProGrade 3D printer that they can run it overnight or maybe run it for multiple days at a time and trust that the part's going to finish. That's what ProGrade printers are designed for. Desktop printers, on the other hand, tend to have a high failure rate, and it reduces your user confidence when you print a part the first time and you walk away from the printer and come back and see a giant bird's nest in the print that you have to clean up. ProGrade printers are designed to print 24/7. That's what they're made to do. So you should have full confidence that if you send a lengthy job to the printer that you'll come back and the part will be finished successfully. If this looks familiar, then it might be time to upgrade to ProGrade. Moving on to number 4. You're constantly working around the size limits of your printer. Desktop printers tend to have quite a few issues around the size of their build envelope. First one is they might just have a small build envelope. And if they do, then you're only fitting a couple parts on there at the most, and that means that when you send a job to the printer and it finishes, maybe it finishes that job quickly, but you're not able to get back to the printer for a couple of hours to remove the tray and start the next job. This generally means that you're going to have a lot of idle time with your printer. Your printer's going to be sitting there idle more often than it is printing, which means your total time to part is significantly longer than just the time it takes your printer to make the part. It may have a reasonably sized build envelope, but inconsistent results across the build envelope, which means maybe you get great prints right in the middle, but if you get 3 or 4 inches away from the middle, the parts start to peel up, or maybe you lose accuracy and you really can't utilize the full build envelope just because it's not consistent enough to do so. Maybe you get decent results with one material but not another, and that becomes a problem when you need stronger materials or different materials for different applications and you can't trust that they're going to print properly. Or maybe the print speed is just so slow that you've never wanted to utilize the full build envelope because it just takes too long. All these problems are solved by a pro-grade printer that prints across the full build envelope size with large parts like the helmet in this picture, or a bunch of small parts just as consistently, just as accurately, and just as reliably, regardless of the material or the number of parts on the build tray. Number 5, your prints don't hold up to your usage. We see a lot of people using desktop 3D printers, and the main material they're going to use is a low temp material like PLA. Low temp materials are really for getting around some of the limitations of a desktop printer. Desktop printers can't print high temp materials accurately because the higher temp plastics, they will tend to curl or delaminate because of the non-controlled environment of a desktop printer. They really need a heated chamber to print consistently. PLA and other low temp materials are generally very brittle, so they're just going to shatter anytime they impact with something. So if you're trying to make a frame for a robot like you see here on the right hand side, the first time you bump that thing into something, if it's printed out of PLA, you're probably going to be reprinting parts, whereas if it were printed in ABS or ASA or PC ABS, you're going to get a lot more use out of it before you need to go back and print those parts out again. Pro-grade printers can print with these high-end thermoplastics just as well as they can with lower-end thermoplastics because they've got that controlled environment. You can expect to get the same accuracy with a higher-end thermoplastic as you would get with a lower temp thermoplastic in the same printer. And that brings us to the entry point to professional grade printing with the Stratasys F123 series 3D printers. Stratasys is the world leader in additive manufacturing. They actually invented the FDM technology that everyone is very used to at this point back in the 80s. So they know what they're doing. Professional grade printer, a lot of times people think that means it's difficult to use or you need special skills, but that's the exact opposite of what this is. What I like to think of is this is made for a busy professional, somebody that doesn't want to have specialized skills. They want to press print, walk away, and come back confident that that part is done, and that is what these printers do. They also have multiple material options, and all of them will print with the same consistency. So you're not sitting there dialing in a new material every time you want to change a material out or have a different application. You put that material in, the machine recognizes it, and it prints that part consistently. They're also highly reliable, and that's really the biggest key here. Reliability is going to be the thing that you benefit most from a professional grade 3D printer. You can press print and you don't have to tinker. You press print, you come back, the part is done. You focus on your design, not on your printer. So with that, if you are interested in learning more about pro-grade 3D printers, or you think that a pro-grade printer might be a good fit for your program, please get in touch using the information on this slide. Thank you.